students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the electric symbols in Ohm's law of chapter 12, electricity of class 10 CBSE NCERT. So we need to study about the electric symbols, how the electric symbols look like in the electricity chapter over here, because these symbols will be useful to us in drawing the electric circuits. Okay, so in electricity we come across different types of circuits having the symbols like this. So you need to understand what these symbols are and what these symbols denote actually. Okay, so the electric cell over here, electric cell, how it is denoted in the electric circuit. Let us take a look at all the symbols over here. Electric cell is represented by two lines like this, positive and negative, having a positive and negative value. Okay, then a battery. Battery, when we combine more than one cell, when we combine many of the cells together, then they form a battery over here. Okay, so this cell, when combined in series, it looks like this. Okay, so this forms a battery. Always understand, a larger line will be represented by plus sign. It shows the positive connection of the cell, and the smaller line will be representing the minus sign that represents the negative side of the cell. Okay, so this side of the cell is said of the battery is said to be positive, and this side of the battery is said to be negative. Similar is the case for the cell also. This side is representing the positive side of the battery, and this side is representing the negative side of the cell. Okay, so now the plug key or the switch open, or we can say switch open. Okay, so plug key, when the switch is open, how it looks like? It looks like this. It is representing an open plug key, open switch, or a plug key which is being opened. Okay, then the key which is closed, it is represented by this, by a dot in between. This represents that the switch is closed, the plug key or the switch is closed. Okay, a wire joint in the wire is represented as this. This is the wire and here is the joint. This dot represents the joint in the wire. Okay, then wires crossing without joining. Without joining, if the two wires are crossing each other, how we represent in the electric circuit? So these are the wires which are crossing each other. Let this wire be L, let this wire be M, denoted by L and M. So when they are crossing each other and they are not touching each other, if they are touching, then it becomes a joint that we represent with a dot. But when they are not touching with each other, we represent with a loop over here. Okay, so the loop is representing that they are not touching or crossing each other. Okay, then electric bulb. Electric bulb is simply represented by this. Okay, it can be represented in a circle or it can be represented simply like this also. These symbols are represented for the electric bulb in a circuit. Then a resistor of resistance R. Resistor having the resistance value R. So resistance is represented by these zigzag signs over here. Zigzag, if we draw a line in a zigzag pattern, it represents resistance over here. Okay, in the electricity, in the electric circuits, the resistance is represented by a zigzag line, and the value of resistance is written on the top of the zigzag pattern. Here it is saying that the resistor is having the value R. So we have written the value over here R. Suppose it is of 10 ohms, 20 ohms or 100 ohms, that value is written on the top of that zigzag line. Okay, then a variable resistance or rheostat. Variable resistance means we can vary the value of the resistance, that is represented by an arrow over here. And a rheostat. Rheostat, here also we can vary the resistance value with this pointer over here. So we can variate the pointer by means of removing it from here and there, and we can change the value of the resistance. Okay, then our ammeter. Ammeter is simply represented by letter A, showing the plus minus values. Plus denotes the current being entering into the ammeter, negative denotes the current leaving the ammeter. Okay, similarly voltmeter is represented by letter V, here also having a plus minus. Okay, so current is entering from here, so it is plus, and leaving, so it is minus. So voltmeter is an instrument to measure the potential difference across two ends. Ammeter is an instrument to measure the current across the circuit, current in the circuit. Okay, so ammeter is always connected in series with the appliances, and voltmeter is always connected in parallel. Okay, across the resistance it is always connected in the parallel, whereas the ammeter it is connected in series. Okay, so these were the symbols which are important to know, because with these symbols only we are able to draw the electric circuits. Okay, in the electricity or in the electrical engineering also, where we need to draw the circuits. Okay, so now we move on to the Ohm's law. So Ohm's law was given by George Simon Ohm, and it states that electric current flowing through any metallic wire or a conductor is directly proportional to the potential difference across its ends, and provided the physical quantities like temperature, pressure should be constant. So it states that the voltage is directly proportional to the current. Okay, so the current flowing through any metallic conductor, through any metallic wire, is directly proportional to the potential difference across its ends. This is our Ohm's law, and it is very much important for the class 10 students, and it is important from the numerical point of view also. Okay, so it was given by George Simon Ohm. So activity is given in the NCERT book, that how it came to be, how the scientists concluded this law. So for that he made a circuit like this. He had taken the battery having the volts of 1.5 of each volt, and he took a nichrome wire XY of having length of 0.5 meters. Okay, and he connected a voltmeter across it and an ammeter across it. Okay, and he took 4 cells which were connected in a battery, and one by one he was connecting it. First he connected only one cell of 1.5 volts. First he connected only one cell of 1.5 volts, and he took the reading of voltmeter and ammeter from there, and he made a table like that, and he took the reading of ammeter and voltmeter and he noted down. Later on he added one more battery which was of 1.5 volts. Okay, so now the battery was equal to 3 volts together. 1.5 plus 1.5 gave him 3 volts. Okay, so for that 3 volts he noted down the value of voltage and current in the voltmeter and ammeter respectively. Then later on he also connected this in the circuit. He disconnected this also in the circuit like this, and it was again 1.5. So in the first case the battery was of 1.5 volts. In the second case the battery was 1.5 plus 1.5 which was equal to 3 volts. In the third case, the battery was 1.5 plus 1.5 plus 1.5, which was equal to 4.5 volts. And in the fourth case, he took all the batteries cells, he took all the cells and he connected them together, and he took the connection from here itself, which gave him equal to 6 volts. Okay, it gave him the 6 volts, and he noted down the values for all the cases for the voltage and current from the voltmeter and ammeter respectively. And when he noted down, he drawn the graph. Then he drawn the graph over here. In the x-axis he took the current, and in the y-axis he took the potential difference. V. Okay. Okay, and he had taken the values and he had drawn the graph, and the graph came out to be a straight line. Okay, the graph came out to be a straight line. That means V is directly proportional to I. So the current flowing in a conductor is directly proportional to the voltage across its ends, potential difference across its ends. The current value and the voltage value was in such a way, he was getting the values in such a way that it is directly proportional to each other. Okay, so when we remove the proportionality sign over here, we get a constant, and that constant is known as the resistance. Okay, that constant R is the proportionality constant. Named as resistance. It is denoted by R, and the unit is ohm. Okay. So from here, there are two more formulas can be derived from here. So V is equals to IR, or you can say I is equals to V by R. Okay. Also, you can say R is equals to V upon I. Okay. So from here it is clear that current is inversely proportional to the resistance, but voltage is directly proportional to current, or current is directly proportional to the voltage, but current is inversely proportional to the resistance. Okay. Now in the exam, 1 volt, they give you to define 1 volt. So how you will define 1 volt? 1 volt is the potential difference, is that potential difference which is coming from 1 ampere and 1 ohm. Okay, which is coming from 1 ampere and 1 ohm. So if they give you to define 1 ohm, so 1 ohm is that resistance which is coming from 1 volts and 1 ampere. Okay, so you need to define in particular manner. So this was the Ohm's law. Ohm's law is very much important from the exam point of view. Okay, in the Ohm's law, again I am repeating, the voltage across the ends is directly proportional to the current, or you can say the vice versa also. The current flowing in the metallic conductor is directly proportional to the voltage across its ends. And so there is a proportionality sign over here. When we remove that proportionality sign, we get a proportionality constant, and that proportionality constant is termed as resistance. Okay, and that resistance is given is denoted by the symbol R, capital R, and the unit of that resistance is given in ohms. It is given in ohms. Okay, so this was all for today. So please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.